why this ripple carry adder is slow? Why this ripple carry adder is slow? So this is your ripple carry adder. Why this is slow? This is slow because the carry must go. Yes or no? The carry must ripple. The carry must go, because you can notice this is slow, because you can notice the answer is very simple, because the answer is very simple, that the S3 depends on, you can notice this S3 depends on C3. This S3 depends on C3. This depends on C2. This depends on C1, and this depends on C0. So you can notice that, first you will, what you will have to do, see this is slow. Why? Because first you will have to calculate this, then you have to calculate this, then you have to calculate this, then finally you can calculate this. Yes or no? So first you calculate this C1, then you calculate C2, then you calculate C3. So that is the reason this is slow. So if you want to make it fast, can anyone suggest some idea? If you want to make it fast, then what I can do? How to make it fast? Anyone want to suggest some idea? This is the drawback. This is the reason why this is slow. Because we have to go, okay, the carry must propagate. The carry must propagate from one adder to another, from one full adder to the next, to the next, to the next, to the next. So the carry must travel through the full adders. Okay, so you can notice initially we cannot calculate S3. Why? Because S3 depends on C3, C3 depends on C2, and so on. So how to make it fast? How to make it fast? So the answer is how to make it fast, and the answer is if we calculate carry directly. Okay, how to make it fast? The answer is calculate carry of each adder. Calculate carry of each adder separately, directly. Okay, so what you do? You calculate carry of each adder directly. Some people call it predict the carry, but that is not a good word. Actually, why? Because we are not predict. See, prediction can be true or false. Prediction can be sometimes good, sometimes bad. Yes or no? If I say that I'm predicting something, what it means? It means that I'm not 100% sure. Yes or no? Prediction means that. Yes or no? Is it clear or not? But I'm saying that we are not going to predict. We are going to calculate. We are not going to predict anything. We are exactly going to calculate the carry. So what we do? Let us assume that somehow. Let us assume, we will see how to do this. But let us assume that we can calculate carry of each adder directly. So then how much time it will save? Tell me. So initially, what you do? First what you do? First calculate carry. First calculate carry. First calculate carries. Okay, I can say carries. So I can say first calculate carry of each adder. First you calculate carry of each adder. Now let us assume that you have now all the carry are available to you. Let us assume, okay, let us assume you have all the carry available. Then what you will do? Tell me. Now all carries are available. Now let us assume that all carry are available. Now what to do? Let us assume you have all the carry are available. Just assume that all the carry are available to you. Just assume. Now what to do? So assume that all carry are available. Means assume C1 to C, I can say assume C0 to C4 are available. Just assume that they are available. Now what to do? If they are available, then yes, very good. Then just add them. If they are available, then all you have to do, because if they are available, then what you have to do? Very simple. Because initially you already have, then all you have to do is this. What you do? So this C0 is available. Okay, already you have this C0 is available. Then what you need? Tell me what you need. You need A XOR B. A0 XOR B bar. This is what you need. But this you can calculate, yes or no. For this you don't have to wait for anything. For this you don't have to wait for anyone. Yes or no? For this you don't have to wait for anyone. Correct? So you can notice that now if this is available, then you can directly calculate. Similarly, now tell me just tell me this point. Now tell me this point, that do you have to wait for this? So this C1 is available. Let's assume C1 is available. Then tell me, do you have to wait? Okay, this is already available. This is already available. And let us assume, tell me, for this, do we have to wait for C1? Do we have to wait for this? Do we have to wait for this? No, because this is available initially. This A1, B1, A2, B2, A3, B3, all these are available at time t equal to 0. So we don't have to wait for anyone. We don't have to wait for anyone. What we can do, we can just directly take and we can calculate S1. Similarly, what you can do, so similarly you can do like this. Okay, this S2 you can do very simple. Okay, the same point, C2. So if you already have this, then you don't have to wait for anyone. You don't have to wait for anyone. What you can do, you already have this, so you can directly calculate S2. You can directly calculate S1 like this and so on. There is no dependency. There is no dependency. There is no dependency. Nothing. There is no dependency. They are working separately. They are working separately. This is generated separately. This is generated separately. We don't have to wait for anyone. Okay. So that is the reason this is fast. Yes or no? So you can notice if they are available. Now all we have to do, okay, if they are available, tell me now, this you already know. What we have to study now? How to make them available. Yes or no? Yes or no? We have to study how to make them available. Like the C0 to C4, how can we make them available? So this is what we are going to do. What we are going to do is, this is the point. So initially you have this. You can notice initially we have all these things we have. For example, AN. Okay, you can notice AN minus 1, or I can say A3. Okay, let's just take A3, A2, A1, A0. These we already have. Initially we have this. Okay. Similarly, initially we also have this. This also we have initially. Also we have this initially. These things we have initially. Correct? Yes or no? These things we already have initially. Now what we are going to do, this is what we are going to do. Now we will create a circuit. What we will do? We will create a separate circuit. We will create a separate circuit. We will create a separate circuit for carry, for all the carry generations. I can say, okay, for carry calculation. So what we will do? We will create a new circuit, a new separate circuit we are going to create. And this separate circuit, what it will do? Using only this data. Remember, only using this data, it will calculate the carry, for carry calculation. And you can notice this data is already available at the time t equal to 0. So using only this data, this circuit will calculate carry. How it will do? Okay. So the point is very simple. But before that, let's understand one point. That is what? Let's see the full adder, the truth table of full adder once more. Okay, you can notice that this is your table. Okay, so you have A, B, this is carry, and this is carry out. This is carry out. Okay, and you can notice that this is your 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. You can notice this is your 0, 0, 0, 1, 0, 1, 1, 1. This is your carry out. Now tell me one more thing. Here you can notice that, just look at this last line. Just look at this. Can you notice that? Can you notice that? Just tell me this point. Here A comma B are 1, 1. Okay, just tell me this point. If A comma B are 1, 1, then tell me, will we get a carry? If they are 1, 1, then will we guarantee get a carry? Will we guaranteed get a carry? Okay, I don't know what is happening here. What is here? I don't know what is here. Now tell me, if I have 1, 1, then I will definitely get a carry. then I will definitely get a carry. I can say definitely I will get a carry. So I can say that they are generating carry. This 1,1, they are generating carry, yes or no? So I can say that this combination is generating carry. This is generating carry, yes or no? This combination is generating carry, yes or no? This combination is generating carry, correct or not? Now tell me one more thing. Look at this combination, 0, 1. I don't know what is here, I don't know what is here, I don't know what is here, I don't know what is here. Tell me this point. This combination you look at. So you can notice this combination is generating carry. Okay, this combination is generating carry. And this combination you look at. Just tell me this point. Will this generate carry by itself? This 0, 1 by itself, can it generate carry? By itself, this cannot generate carry. Remember, this cannot generate carry by itself. But tell me, if this 0 comes from here, means there is no, if this carry 0 comes from here, then what carry will go? If this carry 0 comes from here, then what carry will go? Then carry 0 will go. Very good, very good. Similarly, if this carry 1 comes from here, if this carry 1 comes from here, then what will happen? If this carry 1 comes from here, then carry 1 will go. So can you notice that? Can you notice this combination? Just look at this combination, this combination. This is not doing anything. This combination is not doing anything. This is just taking the previous carry and forwarding. Yes or no? This is forwarding the previous carry to the next. Basically, this is not doing anything. This is not generating. You can notice that this combination is not generating any carry, but the previous carry it is taking and it is forwarding. Yes or no? So I can say that this combination, just look at this combination. This combination you can say, this propagates. I can say this simply propagates. This combination simply propagates. I can say simply propagates the incoming carry to the outgoing. Yes or no? This propagates incoming carry from previous stage to the next stage. This propagates the incoming carry. Whatever the incoming carry is coming from the previous stage, okay, that incoming carry it is propagating to the next stage. Yes or no? Is this clear to everyone? So this combination, you can notice this combination, basically this combination, what it does, this combination propagates. This combination simply propagates. This combination simply propagates the incoming carry. The incoming carry, okay, from previous stage to next stage. Yes or no? It does not generate anything. Remember, this combination does not generate anything. So this combination, this 0, 1 combination, this combination we call carry propagator. So you can notice this combination. So basically this combination 1, 1, I can say this A equal to 1, B equal to 1. This combination is called carry propagator. Carry generator, because this will generate. Yes or no? It is actually generating. It does not depend on what is the previous carry. It does not depend. It is actually generating the carry. So we say that this combination is carry generator. This particular combination is the carry generator. So I can say that this G, this I can define this variable, this new variable I am defining this G. This G means carry generate. This variable means carry generate. Tell me when carry will generate? When carry will generate? When this carry will generate? When A, B are 1. Yes or no? When both are 1, then carry will generate. So that is the reason we define this new variable. This new variable we define, which is called carry generate. This variable is known as carry generate, because in this situation carry will generate. Okay. Similarly, you can notice in this situation, when your A equal to 0, B equal to 1, or when this, or you can notice when A equal to 1, B equal to 0. In these two situations, what will happen? Tell me. These combinations are called what? These combinations are called what? These combinations are called carry propagator. They are carry propagator. They don't do anything. They don't generate anything, they are carry propagator. So you can notice this. So they are carry propagator because they will not generate, they will propagate. So tell me, this new variable I am defining P. This variable P I am defining. This P means carry propagate. Carry propagate. So tell me when carry will propagate? When carry will propagate? In this situation, carry will propagate. Correct? Yes or no? In this situation, carry will propagate. And there is something called, and what about this combination? What about this combination? Can anyone tell me? This combination will propagate or generate? What about this combination? This combination will propagate or generate? Look at this combination. This will kill the carry. Actually, this is the carry killer. You can notice whatever carry comes, definitely it will go 0. So whatever carry comes, 0 or 1, whatever carry comes, the carry is killed. Yes or no? So this combination is called carry killer. Okay, this combination is basically, I can say this combination is carry killer. Or I can say, so I can say carry kill. Carry kill means when carry will kill, tell me. Carry will kill means A is 0, B is 0. When A, comma B, when they are 0, both are 0, A is 0, B is 0, in this situation, carry will be killed. Yes or no? The carry was coming, but this combination has killed the carry. Yes or no? Is it clear to everyone? But this is not useful to us. But this is not useful. We will not use it. But this is just a terminology. Sometimes this term is used by some authors, carry kill, but we will not use it. But you can note this combination will kill the carry. So carry kill means A bar, B bar. In this situation, when A is 0, B is 0, then carry will be killed. Whatever is the incoming carry, the outgoing carry will be 0. Okay. So finally, this is the point. So we have two variables we have defined. What we have done? We have defined two variables. So these are the two variables we are going to use. So you can notice we have a carry generate. We have two variables. So we define two new variables. We define two new variables. Okay. One is carry generate. One variable is carry generate. It is G. When carry will be generated, in this situation, carry will be generated. Another is carry propagate. This is P. And in this situation, carry will propagate. So these two variables. Tell me one thing. The most important thing is this. If I want to calculate this, do I have to wait for anything? This is the most important note. Tell me. To calculate, just tell me this point. To calculate G, P, we don't have to wait for anything. Yes or no? We don't have to wait for anything. Because this depends on A, B. So we don't have to wait for anything. If you want to calculate G, P, you don't have to wait for anything. Yes or no? Is this point clear to everyone? This is important. To calculate G, P, we don't have to wait for anything. So you can notice what is G0. For example, G0 is A0, B0. And what is P0? P0 is A0 XOR B0. Similarly, what is G1? G1 means B1, A1, B1. And what is P1? This is your A1, this. Similarly, what is G2? This is your A2, B2. And what is your P2? This is your A2 XOR B2. And what is G3? G3 is A3, B3. And what is P3? P3 is A3 XOR B3. Yes or no? Yes or no? So this is your carry generate. This is your carry propagate. In this situation, carry will propagate. In this situation, carry will generate. Okay. So these are your variables. Is it clear to everyone? And you can note this P3. To calculate this P3, you don't have to wait for anything. So we can calculate GI, Pi directly. We can calculate them directly. Just tell me this point. This is my question. Okay, we can calculate them directly. Let me ask you one question. If basic gates. Okay, if only basic gates we can use. If only basic gates can be used. Only basic gates can be used, and each basic gate has propagation, and each basic gate has delay delta. Then tell me how much time to calculate P3. Then how much time, how much delay to calculate P3. Then delay of P3. Then tell me delay of P3. Then tell me the delay for P3. What is that? This XOR we have, remember, P3 means XOR we have. So you can very easily notice that, you can notice that delay for any PI, delay of any GI. Okay, let us see GI. GI is basically simple AI, BI. So what is the delay for any GI? Tell me. What is the delay for any GI? That is simply 1 delta. Correct or not? That is simply 1 delta. Yes or no? That is simply 1 delta. Very good. And what is delay for any PI? Delay of any PI. What is that? You can notice PI is AI XOR BI. So we need not, comma, and, comma, or. Yes or no? We need not, then we need and, then we need or. So what we need? So delay of any PI is 3 delta. So that is a 3 delta. So but the point is, after 3 delta, okay, you can notice initially at t equal to 0, you can notice AI, comma, BI available. AI, comma, BI, comma, C0, they are available. They are available. So after delta we got GI, okay, and after 3 delta we got PI. So after delta we will get GI, after 3 delta we will get PI. In the same question, in the previous question, if complements are already given, then tell me. This is my question next. If variables are available in original and complementary form, if variables available in original and complementary form, in available in original and complementary form, then you can notice that delay for GI is again delta, but delay for PI will be now 2 delta. Now it will be 2 delta. Correct? Okay, so delay for GI will be now delta, and delay for PI now will be 2 delta. PI will be 2 delta. Now this is my next question. If every gate, every logic gate has delay delta, then tell me. If every logic gate has delay delta, then tell me. Every logic gate, whatever logic gate you take, every logic gate has delay delta. Then tell me what is the delay of GI and what is the delay of PI. Now this is also 1 delta and this is also 1 delta, because you can directly use the XOR. So here you can use the AND gate, and here you can directly use the XOR gate. Okay, so all these points, are they clear to everyone? Are they clear?